The following presentation is part of the Technology and the Corporation Conference Series, sponsored by MIT's Industrial Liaison Program.
So we're what's between you and cocktails, so I promise we're going to make this really, really interesting. So you guys can stay standing because I'm going to introduce you real quick and make sure you're in the right order to make my job easy. So Tim Copes. Yes. Okay, very good. Tim leads the manufacturing and quality organization and function for Boeing commercial airplanes. From May 2007 until January 2010, Mr. Copes served as president of Boeing Shared Services Group. Under his leadership, that group successfully integrated the management of its internal services into the management systems of the Boeing business units while driving both service improvements and a step improvement in productivity. We're not worthy, we're not worthy. Thank you for being on the panel. Yeah, you do have a bachelor's degree, that's true, mechanical engineering from the University of Wisconsin, the Badgers.
The Badgers.
The Badgers, and a master's degree in mechanical engineering and management from the LGO program. So, welcome, Mr. Copes. You may sit.
Thank you.
Okay, for the next panelist, Mr. John B. Haydon.
2 for 2.
Okay, you guys have been hiding from me all day. He became the Executive Vice President and Global Head of Operations of Phillips Healthcare in May 2009. In 2011, Mr. Haydon took on the additional responsibilities of leading Phillips Group operations, covering healthcare, lighting, and consumer lifestyle business sectors, reporting to the Phillips CEO. Under his leadership, Haydon is responsible for setting the organization's operations vision, strategy, and execution, leading the 60,000 employees of a multi-billion-dollar business that operates in more than 28 countries. You have a business diploma from Algonquin College in Canada and an MBA from Queen's University. Welcome to Mr. Haydon.
Thank
you
you
for being on the panel. Mr. Martin Mrugal is the Global Head of SAP's Manufacturing Industries and Solutions Business. Previously, he was on assignment for the SAP Executive Board, working on a global change program. That sounds like quite an assignment. Prior to his board assignment, Martin held the position of National Vice President and General Manager responsible for mid-size enterprise solution and products. He holds an MBA from Penn State and an undergraduate degree in marketing, also from Penn State. So welcome to Martin.
Thank you
for being on the panel. And finally, we have the very famous Dr. Martin Schmidt. You're all over the internet, by the way. He received his BS degree from RPI in 1981 and his SM and PhD from a very notable institution, MIT. Currently, you're the faculty head for the White House Advanced Manufacturing Partnership, AMP, and we'll hear a little bit more about that from you. Thank you very much for being on our panel. Okay, I have just a couple slides to give us a framework for our discussion. So what I thought we'd do is really put together or show a framework for some of the things we've been talking about today, and I think it will help to guide our discussions on the focus of this panel, which is really innovation in manufacturing. Manufacturing, as we've discussed today, really is not monolithic. Rather, manufacturing is an element of a commons, and really this commons is nested in and of itself. So in the innermost commons, as shown here on the screen, you have a manufacturing commons, and think about what the last speaker was talking about and some of the others today. We heard discussion on topics like manufacturing technology, the proximity of the supply chain, manufacturing processes. We heard about quality system from our speaker from GM, product design and having the engineers close to manufacturing, and IT infrastructure. If you look at most manufacturing companies and where we set up manufacturing, there's some kind of manufacturing support network or ecosystem for that given manufacturing activity. Now, if you step out and pull the lens out just a little bit more broadly, think about the industrial commons. And this is when we expand just beyond what a given company might put together to what an industry more broadly might create, what kind of industrial commons. And this is where the discussion of the U.S. competitiveness comes to play. Some elements in that industrial commons would be the infrastructure, academia, many of you are here today, national labs, trade and professional associations, workforce competitiveness, capabilities, our customers, and we'll come back to them, corporations in the IP portfolio. We get all excited about manufacturing, where it is, what do we do. I think it's important to remember the very central role of customers in all of this, and that's shown in this industrial commons. That really is the anchor for many of us with regards to where we manufacture, how we manufacture, and what is it that we do manufacture. Then if we step our lens back just a little bit bigger, we can begin to think about the global business commons. So very global business world, as I'm sure you all agree today. We can't think of this country in isolation. We have to think rather about how these industries and this country functions in that global ecosystem and what is there outside of the United States and how does that influence our decisions. Tax structure was talked about in the last presentation. IP has been a topic that we've talked about today. Infrastructure, immigration law. How big is the markets? What do the customers want? Can those markets have access to capital? Regulations, we heard about that a couple times today. Trade policy and the political system. So within that context, then, we'll have some of our remarks this afternoon. I'd like to make a comment here that if you think about this ecosystem, just like the ecosystem in nature, the ecosystem can help to create a healthy or an unhealthy environment for innovation. So what we will talk about today is what is it in these three ecosystems that creates a healthy environment for innovation and manufacturing. And for the sake of this discussion, we will really classify innovation as the sum of these two things, ideation and commercialization. You have to have both in order to truly have innovation. So ideation is generating new ideas. Think of it as patents, journal publications, royalties, license fees. So it's one thing to come up with an idea, but that's not innovation. That's ideation. It's another thing to commercialize and have a factory that can just spit out products. That's not innovation either. Commercialization is measured by revenue, value added from new products, processes, and services. This is the factories making things. So those innovative economies are those that can both ideate and commercialize. One thing that the U.S. does very well is innovation, and it is, I'd argue, because we can do both of these well. So with that as a backdrop, let's begin. And I'm going to grill our fine participants who've agreed to join me here today.
So do I have to stand up?
Are you ready? No, you're welcome to if you like to, but no, you don't have to. So everybody loves an airplane, and in fact, on my way here, I had the most entertaining flight I think I've ever had. The guy was spouting off all kinds of fact on how much fuel burned and everything on the way here. So, and he talked a lot about your wonderful Boeing 737. But the question I've got for you is really around the 787, and it's an airplane that we've heard a lot about. It's long awaited, innovative airplane that really stretched the boundaries of product and process design. Really stretched you and stretched the industry, and I'm sure will be a platform for your profitability here for the next 20 or 25 years. It's really a good example of our definition of innovation. I'd imagine there's quite a bit of ideation in there as well as commercialization. So can you tell the audience a little bit about the process innovations that you planned into your program? I'm sure there's a lot of that planned into the program, and then I'm sure as you went through the product development process and process development process, you innovated along the way as well. So maybe you can tell us a little bit about some of those innovations.
Yeah, sure. It's kind of an interesting question because when you're a manufacturing guy at Boeing, I haven't heard the word ideation before, but usually we're the guy standing between the ideation and doing a cool new airplane just because we can't build it. And on the 787, maybe a good example, and it was only good that Jeff Turner was here from Spirit. The composite fuselage is a great example. So carbon fiber composite, black plastic. It's a material system that was developed and used in aerospace in the 80s. We used it a little bit on the 777, but we could never find a way to economically make it in the quantities you needed to make a fuselage, which would really enable a lighter structure and some cool things like lower Kelvin altitude with really no weight cost penalty. But to do that, you have to figure out how you're going to lay down thousands and thousands of pounds of this composite in a very precise manner, and then cure it, and then inspect it to make sure it's right, and then integrate everything else that goes into an airplane with it. And I don't know if many people probably weren't surprised when we announced that the 787 was going to have a composite wing, but I think many, if not most people, were surprised when we said we were going to do a composite fuselage. So to your point, being able to take that from an idea into a reality on that using a global supply chain, because those composite fuselages are now built in Wichita, Italy, Japan, and South Carolina. So it's really built in 4 different pieces using the Boeing technology. That's a really good example of that.
I was reading an article not too long ago. You can't really believe everything you read, can you? So I guess you'll correct me if what I read was wrong. But what I read was that as you've been putting this airplane into production, getting ready for that, you've actually co-located quite a number of your design kind of people into the plant to help make that happen, that transfer happen. You said you were the guy standing between ideation and the airplane getting to production. So is that true? And how, or is the look on his face suggested it was propaganda?
No. It's it is absolutely true. I was worried you were going to ask me a harder question on 787. That's why I had the look of concern.
We're not here to grill anybody.
You did emphasize the long-awaited. So that was a little, maybe a little bit worried.
All right, but I've had all my bleeding edge on diesel engines, and if one of them doesn't quite start the first time, nobody dies. So we all appreciate that you wait to get it right, don't we?
Yes.
Thank you.
The co-location of the engineers with the production environment we actually did before the 787. There was a fair amount of, as most people would know, we in aerospace are typically not the first movers. So I worked at IBM in the 80s. And the fact that you need to design the product and the production system at the same time was kind of old hat. In Boeing, we're a little bit slower to adopt that. And the best example of that was the 737. They actually invested a lot of money and put glass walls in and actually moved the entire engineering team into the factory and tore down the old engineering building. So by the time we got to the 787, we knew that was essentially one of the essential things that we were going to have to do. But what's interesting is it's more of a challenge when you got a globally distributed production system. So we tried to go light on that at the beginning, and as we started to introduce the product into production, we found it out we needed to forward deploy a lot more Boeing resources around the world to make it work.
I see. So that was going to be my follow-up question then. How did you bridge that gap since you had a global supply chain?
It's a lot of boots on the ground. So I think the realization of the startup challenges you're going to have in this integrated system, one of the things that we could apply was we could apply our global know-how. So we've got a lot of alumni from the LGO program deployed all over the world through the course of this. I mean, if you want an international experience, you worked on the 787, and if you didn't get sent to Japan, you got sent to Italy. If you didn't get sent there, you got sent to Tel Aviv. So we put a lot of our expertise out to the supply chain to help them through the startup challenges.
And I guess I'd comment, that's one thing I've seen shift in the 20 or so years that I've been working, and it is that it seemed like 20, 25 years ago, we used to give foreign assignments to people and you'd ship them off, they'd have their foreign assignment, and then they'd come back. And today it seems like there's maybe, yes, there's some of that, but no longer is being part of having a global organization abdicated to those few people who take international service assignments. Rather, I think everybody has up-to-date passports and does an awful lot of traveling.
Yep.
You guys agree with that?
Absolutely. Yes.
Okay, Mr. Haydon. So you have the very Tony title of being the EVP of operations, which means that these guys that commercialize and get stuff to production work for you. So you probably like this idea of engineers spending time in the factory and knocking down the engineering building and putting the engineers inside a glass wall. Must sound like a really great idea to you. I'm asking you, what do you think of all that? How do you guys get your engineers involved in the manufacturing process?
Maybe what I'll do is just take a bit of a step back and sort of talk a little bit about Phillips Healthcare to set the stage, and I'll come in and sort of talk about what we're doing around a value chain, bringing engineers into all aspects of the value chain. So the healthcare business is really focused around 4 sub-businesses. We have an imaging systems business, so MRIs, CAT scans, nuke med, very large capital equipment. We do a lot around healthcare informatics, so we're similar to like Dell, shipping computers, but very sophisticated computers that are mounted on hospital walls. We have a home healthcare business, around respiratory and sleep, and then we have a services business. So it's truly a global business. We're in all four corners of the earth. Our approach now is really around moving from a supply chain mentality to a customer value chain. So you said it earlier, it all starts with the customer. And you look at the healthcare customers, they were very local in a country. Now they're becoming very regional, where you're starting to see hospitals expand in cities, as well as provinces and states, and eventually other countries. I'm not too sure it's ever going to go global, per se, having a hospital chain around the world like you have in, say, telecommunications or other industries. So our approach right now is to develop products local for local, global for local, and in some cases, very, very, customer-oriented. So if you stand back and you take a look at how we bring that chain together, how we involve the engineers, our whole concept now is around the value chain of an idea to market, so the innovation piece, market to order, how you bring something into the marketplace, and order to cash. And we've tried to create a whole process ecosystem around that. And as we go around the world, we can use common platforms in our products and common processes, so we can develop things in Sao Paulo, Brazil, or in Cleveland, Ohio, or in Tel Aviv, or pick a place type of thing. So I think it's important, from a manufacturing perspective, that we're knee-deep with the R&D organization. And I think it's great to bring the R&D organization into the factory. Also, you need to bring them into the field when you do installations, because you also need to make sure you can manufacture for installations. I also think you need to be partnering with the sales organization, purely from a demand perspective.
So you mentioned, local for local and global for local.
Yep.
And going all the way from innovation, through the supply chain to delivery to the customer. And that you use some common processes in order to weave, I guess I'll use my own words, kind of a common thread to make sure, I'm assuming that you are
Correct.
Delivering the kind of quality your customers expect.
Yeah.
As well as leveraging the scale of your company. Working for a big company myself, and I'm sure my colleagues will agree here, one of the things that we always struggle with is how much common process do you push, and then how much do you let, in order to foster innovation, do you let, say, the local design and manufacturing people innovate to meet their unique market needs? So how do you draw the line of where we all have to be standard and drive that standard process, and where you'll let people innovate?
So I think it's a balance, obviously, but I also think if you're really going to drive scale and you're going to drive cost innovation, you need to harmonize and standardize in some areas. So as we look across the company, our belief is we need to be a lot more process-driven. You never want to lose innovation or customer centricity, but if you're going to drive operational excellence, you need to go in and look at your processes. Your IT systems drive a lot of what's going on in the company. You can't put IT systems in if you don't understand your processes. So the whole sort of structure here is around 50 core processes. So things like purchasing you can standardize on. Whether I'm doing purchasing in China or purchasing in the States or purchasing in South America, it's purchasing. Now when you look at innovation, that's where you need to be different, okay? The Chinese guys innovate very differently than the Americans or the Israelis. Market conditions are different. Customers have different expectations. So I think, on the innovation front, you really need to make sure that you are local depending on what you're doing. But for instance, if you're going to do transducers for ultrasound machines, that's where you really go global. So we use a balanced approach, but very process-driven.
Yeah, that was a good answer.
Thank you.
One word that we, because
I practiced that this morning.
Yeah.
because if it wasn't, by golly, you'd be standing up for the next question.
You passed, yeah.
The comment I was going to make is that, one word that we use is define where we're going to let our engineers, whether they be manufacturing engineers or product designers, we try to define the space where they can innovate and differentiate, and then other places that they're standard. And that's part of the art of business, is drawing those boundaries. So now we're going to move on. Are you ready?
Good luck.
I'm ready.
Okay, good luck. Mr. Mrugal.
Yes.
So SAP, you're well known for innovation in software and systems, and in fact, you're one of these drivers of, for the rest of us, a common process, because it's just tremendously expensive, burdensome, cumbersome.
A few more words.
Yes, yeah, painful,
And you don't have any choice.
slow, yeah.
But we love you.
If you commonize, but we love you. We love you, man. if you commonize, it's in all seriousness, one thing that I think many of us have tried to derive for as we've implemented updated systems like SAP to really reap the benefits from that. We've really pushed people to have common process, because the minute you get into making special variants of the software for any one of us, we really lose out. The companies lose out on what you guys have to offer with regards to cost and the performance of the software.
Absolutely.
So can you remark on the impact of business system software on improving the efficiency of a company's manufacturing commons, and also then how that helps us in industry to innovate?
Sure. So for us, we started in 1972 with 5 IBM engineers, and their focus was absolutely on those commons and integrating those processes in the commons. So they started with financials, and they said, okay, now that we have financials, we need to integrate order management, for example. Right? And so order management was integrated to financials, and the next step was, let's look at some of the other processes like logistics execution, manufacturing. And so that commons, that was really their vision, to integrate those commons and establish some best practices and processes around those commons for exactly, John, what you said. Right? You want to establish those common processes. Jeffrey Moore had a comment about core versus context. Right? And he said that core is what gives you competitive differentiation, and context was everything else. And so what we tried to do, especially early on, is focus on those core best practices. And our advice when companies are implementing enterprise software is to basically let the software do the context, those best practices, and implement those context practices. But for those core, those competitive elements, that 20% that really gives you a competitive advantage, really focus on that, and that's where you spend your time in the implementation. So, I think that certainly we have many customers, not just on the panel, but also in the room, that have reaped significant benefits from employing that strategy. And I think really we're just scratching the surface in terms of that early vision. Because if you look now at the technology that's coming at us, and the Wall Street Journal did an article earlier this year, and it was entitled "The Tech-Led Boom." And it talked about innovations such as mobility, and it talked about big data, and it talked about smart manufacturing as the 3 of the biggest elements that will impact the innovation cycle going forward. And I truly believe that that's the case, but it's not just those 3. It's also things like in-memory technology, analytics as well. So there's a lot of technology that's really coming at us for the first time in really generations. So you think about even the internet, it's not that old. So with the impact of all of these different technologies, it will basically increase the opportunity to take what was done in the commons originally and further expand that. So I'll give you an example for mobility. One of the things that we're doing is we're working with Tim's team at Boeing to take the iPad to the shop floor mechanic for the airframe. Now Tim will tell you that, and correct me if I'm wrong, the mechanic goes up and down that airframe quite often in assembly to do things like conformations, check inventory, check drawings, etc. So what we've done, Boeing runs our software. We basically put that software on the iPad. The mechanic goes up into the airframe. Now if he wants to check inventory, he wants to check a drawing, he wants to do a work confirmation, he does a quality check, he does it all from that airframe. And you talk about the impact, you think about the number of employees that Boeing has and the impact that mobility will have in manufacturing. It is absolutely significant. You take another technology like in-memory technology. We call it HANA, but it's basically the ability to process 100,000 times faster than you can do today with big data. We're working with a semiconductor manufacturer, and we've connected their PLCs and some of their manufacturing equipment to our in-memory database to basically see what were the settings on the machines as they were producing. Right? And a small percentage change in yield for a semiconductor manufacturer has multi-million-dollar impact to them. And so what we did is we first looked at the data and we said, wow, we can't read this. There's so much data here. That doesn't make sense. So then we started to apply some heuristics and algorithms to it, and we started to see what the variability was, and we could see what the settings were in the machines. Right, so now you take a snapshot of, you can see that where the machine settings were that produced the highest yield for the semiconductor manufacturer. And that has a huge impact. So that's in memory. So we've talked about mobility in memory and analytics. You know, the speakers this morning talked a lot about analytics and the ability to really analyze. It's not just about the big data. It's the analysis of that data and the business insights that that gives you. And the implications that that has for your business are significant. But it also has implications for the types of employees you want to hire in the future. Right? You don't just want to think about your employees today and the requirements, but if you're going to start to analyze data in new ways, and you're going to have new data coming, for example, from machines and devices and all these sensors that are out there, then you're going to need people that understand how to interpret that data and the impact that data has on business. So, it's not just the commons and what we've done originally in terms of our vision, but it's also about the future technologies and its impact on manufacturing. I am absolutely bullish it's going to revolutionize manufacturing.
That's good to hear. And we were talking at lunch about innovation in manufacturing and the 80-20 rule that we heard from one of the first speakers. And commenting on, I think he made the comment when he was talking about robots, that if you can get 85% of the functionality, make it the product easy to use and readily available like you've done with your iPad, that's a lot better solution than having something that's really 100% efficient, but nobody can use it.
That's a great point. So, and just like robotics, software was certainly guilty of thinking about putting all of that functionality into one screen or two screens, right? I mean, it was all there. And it really is more about the usability. It's a great lesson learned, and that's our focus now as well, to think about the different types of users that are using the software and making it very simple. It's not that that functionality goes away. It could be brought back to bear depending on the user, but it really is really tailoring that user experience, and that's really our focus going forward as well.
Good. So Dr. Schmidt, we'll turn to you now, and we'll back you up to one of these broader lenses and talk about what you're doing with the Advanced Manufacturing Partnership. And the objective of this is to help drive the U.S. economy forward to make I guess I'd say, a more favorable environment and ecosystem for advanced manufacturing. And it has 4 different work streams: technology, education, workforce, and shared infrastructure. I'm going to redo that. Technology is 1, education and workforce, right? Shared infrastructure and facility, and policy and outreach. So maybe you can tell us a little bit about each one of those work streams, and then I'll follow up with a question.
Sure, I'm happy to do that. So let me just say, we're fortunate in that our president, Susan Hockfield, co-chairs this Advanced Manufacturing Partnership with Andrew Liveris, who is the CEO of Dow Chemical. The partnership is a collaboration of 12 universities, 6 universities and 12 companies, but has reached beyond that group to really gather a lot of input. I've had the good fortune of supporting Susan in her role as co-chair. So the perspective I'm going to offer to you is really what's been gleaned through the various outreach engagements that AMP has had, and some of the recommendations that Susan and Andrew have shared publicly in a briefing to PCAST recently. The final report for AMP we hope will be out shortly, and I think we can all see that when it comes out. But as you suggested, there were really, AMP got its work organized around 4 work streams, and as an academic in electrical engineering, I'm not going to try and talk to this group about policy issues like taxes and regulatory reform, but I can assure you that was a vigorous part of the discussion, and I'll just simply say things like R&D tax credit stability, sensible regulatory structures are certainly issues that surface as of importance from a policy perspective. About workforce, I think one of the interesting things is a common theme we heard across all of the work streams, but maybe the workforce development is where it became most strongly articulated, was the issue of image. A deep concern that the image of manufacturing today is not correct. The view that manufacturing is dark, dirty, dingy, and dangerous and that high school guidance counselors are discouraging folks from considering careers in manufacturing is a problem that we think we need to address. And that clearly is a critical issue in terms of sourcing talent. I think there's a lot of opportunities collectively, and I think that's the power of AMP, bringing together academia, business, government, and community leaders to think about how do we turn the tide and get people to realize what the real opportunities and excitement of manufacturing is. Without that, we're not going to address this the sourcing of talent. The other thing that comes through very clearly in the workforce work stream is the issue of the skills gap. We hear very clearly from many of the companies we talk to, large, small, medium, the fact that they're challenged to find employees to fill jobs. I would say that there are folks that would dispute that from an economic perspective and looking at wage tracking, and so we have work to do to really get the facts out on what the skills gap is. But AMP, I think, heard that and understands that that's important. And I would say that what comes across when you think about that is a lot of the workforce need is at what I would call the community college level. And so there's a strong sense in AMP that that's the sweet spot for impact. We clearly need to do better in K through 12. Hear scary stories about companies wanting to hire workers, 100 people apply, 50 fail the math competency test, and some overwhelming percentage of the remaining fail the drug test. So working on K through 12, true story, working on K through 12 to really, develop a better workforce. And at the higher ed level, I think we have a lot of things we can do in terms of curriculum development, injecting manufacturing principles into a lot of our basic engineering curriculum. But at the community college level, that's where we really could make an impact. But I think it's interesting, and I'll share this as an anecdote. We held a regional meeting on advanced manufacturing here in Boston in late November. And we had a manufacturer from New Hampshire, runs a 100-person company with a precision machining operation, speaking very passionately about his concern about all of his machinists being over 50 and unable to find people to fill the pipeline, and imploring community colleges to stand up courses to train those folks so that he could hire them. No sooner had he stood down from that comment than a president of a community college in upstate New York stood up and said, I just had to cancel that class because I didn't have enough people in the seats. And so it's a way of saying, maybe we need to think about the educational delivery model as well, because as many of you may know, community colleges, one way in which you optimize community colleges is to shorten the time it takes to get from home to the community college. These folks are people that have multiple things going on in their life, and distance to the campus is a challenge. And that optimization around distribution flies against this challenge of getting bodies in the seats. And I think it's very exciting to think about, for example, it's a self-serving comment being someone from MIT, but we are really excited about what's happening with MITx and the experiences in remote and distance education and flipping the classroom. And maybe some of these innovations in education can percolate down into these levels and really have an impact. And I think it's going to take everybody thinking about this and helping the community colleges. We can't just open a box that says community college, shake dollars and close it and hope that that's going to solve the problem. Right. Industry lead is really critical on this. And there are lots of good examples. Stark State's participation with Timken in the development of workforce. On the regional side, we hear a lot about the need for infrastructure to support the transitioning of technologies from universities, national labs into industry. And this past month, or I believe at the previous month, the president announced the National Network for Manufacturing Innovation, the idea of creating a set of regionally distributed manufacturing innovation institutes that could sit between the R&D occurring at industry or universities and the industry and facilitate transfer. So I think that's an interesting outcome that the first pilot institute will be created by DoD in the area of additive manufacturing. And then lastly, in innovation and technology development, a lot of discussion in AMP and what are the technologies that are really important to secure our leadership in manufacturing, and thinking about disruptive technologies, technologies that break through barriers that preclude us from manufacturing domestically. If it's about labor costs, then what about robotics? If it's about energy costs, then are there low energy manufacturing methods like biomanufacturing methods that might replace conventional high temperature temperature processes. So thinking about some of those core technologies and also encouraging the development of a national strategy for identifying these technologies. I think those are the sort of overarching conclusions that start to emerge from all these activities around AMP.
That was very good. I
Thank you.
I won't make you stand up in the white hot bright light, though I'm sure you've been in those before. So what I'd like to do is follow up with the other panelists on following up on what Dr. Schmidt had to say, and perhaps let's touch on this workforce issue in education. Of all the topics you described, in my opinion, that's perhaps the toughest to crack because there are multiple root causes to the problem and you have multiple dimensions to the solution as well. How do you get people interested and capable of even taking those courses at the junior college? And you mentioned that this is an area that you think that industry and academia could work together. So, I'm curious to my panelist colleagues here, what do you think of that comment? What ideas do you have of how academia and industry could be working more closely together to get the pipeline of the next generation of manufacturing engineers?
Yeah, my first thought is I do think you're right about the sweet spot. I mean, as many problems as we have, at least you hear a lot about concern about K through 12. And you always, it's pretty easy to worry about the higher end technical education, whether it be at MIT or someplace else. But, for the kind of jobs that the manufacturing is going to be in this century, it really is more than a 12th grade education and frequently something less than a 4-year. And it's kind of it's a silent critical mass within the American system. But I think your idea of the public-private partnerships, we on the company side certainly can't do it alone, but we can help. I know we've just opened a very large facility in South Carolina, and we found them very open to working with us to put special programs in place that would allow us to literally transition people from high school, give them those skills, and then help put them on a track to come into the Boeing workforce so that we don't have to train them again on the same things that they're being trained on. And I really do think there's a lot more potential for partnerships like that.
Either of you have comments in that regard?
I'll jump in. I've seen two really good models in my career, one in Singapore and one in Northern Ireland, where industry, universities, and the government come together to build an ecosystem. So if you take a look at what Singapore has done, they'll bring you in, they'll court you in, they'll help you set up, the right courses in a university around your type of manufacturing. Obviously, they provide subsidies, and they even go as far as helping you get into places like Indonesia or even into China with the Singapore Industrial Park. So I think models like that are very, very powerful where you bring the three bodies together. I find in North America that we're too siloed and we have pockets of excellence where we're coming together, but I think you need more of a structured approach where you're actually courting companies to come on in and, yes, we can help you with the education piece, we can help you with tax incentives and subsidies and whatnot, and obviously the industry has to bring something to the party too.
Yeah, I think, from a technology perspective, I have two thoughts. One is we do have a very strong University Alliance program today. What I don't know is how strong it is at the community college level, and that's one takeaway that I have from the panel. And the other one is in terms of maybe a partnership with usability and technology. Because let's face it, technology is kind of a cool factor, right? And if we could maybe create some programs and some models that make younger kids interested in business software and technology, that could actually help as well. Mm-hmm. Bringing things to the iPad. I was in a manufacturing plant 2 weeks ago, and it was a young adult. I would say he was in his early 20s, and he had a Kindle Fire, and he had all of the information on his Kindle Fire, and he was really proud of it. And so that confidence that it brings, this generation has grown up with information technology, and maybe we can leverage that to attract it from an education setting. So that's just another thought.
Yeah, I mean Dr. Schmidt's whole point about branding. Do we have a brand problem with manufacturing?
Yes.
And it's I hadn't thought of it until you said it, but I think that's undeniably true. And your idea of bringing the fact that manufacturing just isn't old tech anymore,
right.
It is high tech, would certainly be a big help in changing that.
Yep.
And it's incumbent upon us really to help make that happen, and through, I think, to your point, using technology like the iPads could make a big difference. I have a daughter, she's now 25, and she's going to be getting married soon, so I'm very glad we're all done with the serial dating. Some people are serial murderers. My daughter was a serial dater. So anyway, she dated one of every kind of guy. And I remember when I was running our electronics division, we were working on joystick controls that really are just exactly like the Game Boy things, or whatever you guys call those now, Wii or... Anyway, so one of these fine young men, he isn't the guy she's going to marry, but anyway, still was a fine young man. He and she came out to see me one day at Cat Electronics on a Saturday, and he said, "What are you working on?" And I said, "Well, we're working on that." And I, pointed to one of these joysticks, and he just, reached his hand up and grabbed that control and started manipulating the buttons. How's this work? And twisting that, and I thought, the machine that we were putting that on is the hardest machine on a job site to run. It's called a Moderator. And it's the job that you get after you're really experienced. And so we went to joystick controls to make it easy to operate. And I thought, you might have a future, young man. Maybe we could get you to run a Moderator someday. Anyway, that's the role of industry too, is I think of making it easier, making it more appealing. And we try to reach back into the junior colleges. One of the gaps that we have is with service techs. Kids that have a little bit of a technology bent today seem to want to go work on computers or something. They don't want to go work on, something dirty, car or, big piece of Caterpillar equipment. So we reach back into some of the junior colleges actually all around the world, and we sponsor a program called Think Big. And we give some scholarships to try to get kids interested in that. So I think there are multiple things that we can do. It's really comes back, on us in the industry, and we're just really happy to have some help from academia in that regard as well. So we're coming upon the end of our session. I guess I'd like to go, down the line here. If there's anything that you really wanted to say, that you didn't get a chance to say, please make it nice, especially with regards to the moderator. Let you make a couple closing comments if you missed anything, and then we'll open it up to the audience for questions. So, you want to start?
Other than I'm wanting to hear the story of how your daughter's choice of mate came. I have nothing further to say. Right,
yeah,
exactly.
2 engineers for parents, and she picked an accountant. How can that be? It's not right.
I'm speechless. I think these type of events are crucial. I think we need to do more of it. I think, us in manufacturing need to take more speaking engagements. You see a lot of our counterparts in the, research and development areas, as well as sales and marketing out there, but we need to get out there and tell people what great jobs we have and great careers that we have. The branding issue, I think, is right. We need to do more, speak up around manufacturing and what we do.
Yeah, I agree.
Yep. So.
Yeah, I also agree on the branding, and I just want to address one point about the, how long it takes to implement software, et cetera. So I can't leave the panel without at least saying that.
Can we talk about cost too, Peter?
And cost. So one of the things we've actually been doing is thinking about how we productize software with services. Because today, a lot of the software is basically engineered to order in the field, meaning Caterpillar engineers to order it, Boeing engineers to order it, et cetera. So how do we productize that, and how do we think about pre-engineering the services with the software to reduce that ratio of software to services? Right? And so we have this thing called rapid deployment solutions. We're actually doing that now. And it's actually being very effective to the tune of about a 40% reduction in time to implement the software. So I just wanted to say that we have heard that before. This isn't the first time. But we are making strides to actually think about how we productize more and make it easier to use, not just from a usability, but also from a deployment point of view.
Well, you have almost an impossible job because we all have our own processes, and only generically can they be described as the same.
Yes.
And you have to come up with a software solution that we can learn immediately and put to work very quickly and make us more productive and innovative. So my hat's off to you. I wouldn't trade you jobs. Dr. Schmidt, did we miss anything that you would like to cover?
No, I think I would just say many of you after today and tomorrow, exciting day, are going to go back to wherever you live. And I guess I would encourage you to think regionally. I think one of the things we've learned is there's some real opportunities to act regionally to make a difference in advanced manufacturing. And if that's going to knock on your governor's door or your Secretary of Economic Development to get your state thinking about this, whether it's talking to your community colleges, your business leaders, but we have to be organized regionally. We can't just rely on the federal government to sort of do some things that are going to change it. There's a strong regional play in this.
Yeah, right. And I guess every time, there's a saying, every time you've got one finger pointing out, there's three back at you. And I think the same holds true of us in industry. I agree with you. It really is incumbent on us to get out there and sell our message, whether it's with regards to branding and the great careers in manufacturing or what we like to do to have a more favorable business climate. It's really incumbent upon us. So with that, we have about 10 minutes left, and we'll open it up to Q&A now.
So I think we have a demonstrated cultural disconnect. We saw right here in front of us. Our colleague from SAP said tech. Everybody on the panel nodded because tech is high tech. But I've flown on a 737, and I've been in a medical imaging device, and I've been in a mine, and those are techs too. Mm-hmm. So I say high tech, you think IT, but I don't. And I think the younger culture does, and that's just a demonstrated issue that we're having. All the programs in the world aren't going to break that until we fix that part of it.
Yeah, fair point.
Good point.
Yeah.
Yep, fair point.
Agreed.
So this is, first of all, I want to thank you, Tana, for opening up the good framework. So we learned something about definition of innovation being ideation and commercialization, so thank you very much. Second comment was, I like the way you moderated. From the perspective of an audience, I don't know how the panelists felt, so that's just a comment.
We're not saying anything until we're down.
Yeah, right. Exactly.
And I would love to just kind of observe your staff meeting, but that's for another time.
Yeah, that's not quite so fun.
Right. So my question is, so because this is about innovation, could the panelists just talk about like an enterprise process that you guys have in your company that tries to get both the ideation and the commercialization ideas, both in the evolutionary area as well as the revolutionary areas? Did you understand the question?
Mm-hmm.
Okay.
So I guess I'll make a quick comment. And what we do at Caterpillar, this mostly is directed towards product innovation and product technology. But what we have is some bold goals set out for the future for each one of our areas, machine-to-machine systems, engine, and in energy, as well as automation. So we have some bold goals set for ourselves for 2020, and those bold goals are performance, cost, and we don't know how to do them today. They're sufficiently bold that they stretch our researchers to come up with something, brand new. And then we have a selection process for selecting the most promising projects to help us achieve those bold goals by 2020. And we really manage our innovation using the same process that NASA uses. The TRL will be modified for Caterpillar, which is why your job's so hard. Everybody's modifying everything for their own use. But anyway, we modify it for Caterpillar and then just have a series of stage gates and then down select to get that into the next generation of new product programs. Anybody else?
Yeah, you mentioned, when you were talking about my bio, you talked about the board assignment. You said it was interesting. So that board assignment was really to look at our processes internally from a software perspective, from when we had an idea for a product to when we actually signed the first contract with a customer. And to really think about how we do that. And it was really frightening, quite honestly. We had a waterfall model, and it just took too long. And in a German company, a lot of times a board member is responsible for a functional area of the business. So kind of driving across the functions, whether it was really illuminating. And so we implemented Lean, and we did Agile and Scrum processes, got customers involved earlier in the process in terms of ideation. And the other thing we did is we opened it up. We said we really need to think about our partners, like Accenture spoke this morning, or Deloitte and others, to help us innovate and build on our platforms. So we're not just thinking about internally about kind of streamlining that ideation process, but also looking externally at our partners to help kind of drive new ideas, new products to market.
That's a good point.
I was just going to add, we talk about innovation, we talk a lot about products and services. And when people say, John, what do you think about innovation? I go, well, cost and cash are two places where we need to innovate. So when I look at cost innovation, I try to talk about how we can be better, around lean or manufacturing overhead. I generally don't talk about cost reduction. It's sort of got a negative connotation. So I want the team to be innovating on cost. Now, when you look at cash, that's a lifeblood of any company. And inventory ties up cash, accounts receivable, supplier payable. So it's the same thing around cash innovation. So I think us in the supply chain play a big role around product innovation, helping the R&D guys and the sales teams understand how we get something that we can manufacture. But we got to be focused on cost innovation and cash innovation.
Good.
So.
Yeah, right there.
I'm fairly familiar working in the union environment with UAW, the IAM, where the average age of the workers is about 50, 55 years old. The problem that we have, in addition to finding the right workforce, the young workforce, is once we have them, keeping them motivated, specifically when seniority is the be-all rule of progression. Is there anything that you're doing in your companies to try and drive that progression for the new employees, that it's not solely based on seniority?
Yeah, I'd give you one thought. Coming to work every day isn't all about advancement. And I think if you think about it, advancement may not even be in the top 2 or 3 on the average day. So one area that we've had a gap that we think's got a lot of leverage is just engagement. We don't have self-directed work teams. We've got a fairly traditional work structure, and the areas where we do, and we've been able to transition to more of a self-directed work team, involve the employees more in their work, make the definition of success more than just getting the job that day, but actually improving and innovating. They're a lot more satisfied, but they're also a lot more productive and a lot more engaged, and you really get a virtuous circle going. So it's a hard thing to do, and it's probably a multi-year journey, but we really think that's what's going to pay off. And I think what I'd tell you is some of our most successful implementations of that have been in a union environment. Because at that point, the seniority system largely is irrelevant on a day-to-day basis.
Germany seems to be doing a lot of things right when it comes to product innovation, as well as being successful on the manufacturing front across a range of industries, right? Automobile, healthcare, and so on. And they have the apprentice program for manufacturing.
I agree.
Even for college degrees, even for PhDs, you have this work study that is almost mandatory.
Yep.
Are we looking at those kind of ideas to adapt and implement in the US?
Yeah, so let me maybe direct that to you, Dr. Schmidt, because I believe you all studied Germany quite a bit in your AMP initiative.
Well, not as much in AMP, but I would say that the Production in the Innovation Economy study at MIT has been looking at that. And I think it's true that the apprenticeship system in Germany is phenomenally successful. If you look at what the core elements are that make that successful, it's not clear that that system in and of itself transplants directly to the U.S. There's, you have a larger union presence. They play a very heavy role in the definition of the apprenticeship system. Frankly, we have a challenge in this country, which is how many of your 25-year-old daughter, did you encourage her to go to the manufacturing floor, or did you encourage her to go to a 4-year degree? So we have a challenge in that largely folks want their children to go and pursue a 4-year degree. And so there's a lot of things in our ecosystem that I think would challenge the importation of a German apprenticeship system. That said, when you think about what can we do at the community college system that could really make a difference? When you think about what might be possible in 4-year degree programs that excite people about opportunities in manufacturing and maybe put a subtle spin on the curriculum in a way that drives it that way. So I think we have to think about the levers that we can control in our society and how you can make an impact.
Yeah, I agree. I think sometimes it's so easy to just point to something that looks like it's working from where we sit and then wonder why we can't adopt it. But we do have our own ecosystem, our own unique strengths, and how can we learn from others, take the best of the best, adapt it to our ecosystem and get us positioned to win.
Yeah, there's got to be a way that we can adopt some of the elements of the German system and apply it to our ecosystem. Because we run apprentice programs and they don't scale. I mean, the number of employees that we get through the apprentice programs are probably 1 or 2% of what our total needs are. So getting people to make a multi-year commitment, I mean, I go to the graduation ceremony, I hand out these certificates, and you think that the ringer we put these guys through, they're just not too many that are going to make that commitment. As a matter of fact, in the last graduation ceremony we did with 9 people, the average age of graduation was over 40.
Jeez.
Wow. Right? Because it was Boeing employees that, after working 10 years, made the commitment to go back. So we've got to find some way to be able to scale it, pick up the critical elements that are absolutely necessary and adjust it for our ecosystem, as you put it. I think you're right.
Well, I think we're at our time here. I guess I'd like to sincerely thank each one of my colleagues here for sitting on this panel and bearing with my bad humor. So,
Great job.
Thank you.
Good job. Good job.